Hello everyone, you are all welcome to lecture number 1245, and today's topic is the chemistry of 6-member heterocyclic compounds. And the first compound what I am going to discuss is pyridine C5H5N, and here in this ring one of the nitrogen is hetero, is the part of ring, and it is aromatic in character. It is having sp2 hybridization, and it is very I can say good aromatic compound. And one more thing, when we are talking of pyridine, it is having aromatic character, we know, but at the same time pyridine is one of the most important and powerful solvent system, organic solvent. I mean, whatever complexity is there, if any substance which is not soluble in any organic solvent, I am talking of organic compound, then we will proceed to dissolve it in pyridine. And pyridine nowadays is widely used in pharmaceutical industries, in drug industries, pesticide industries, textile industry, everywhere. And in most of the cases, they are used as a derivative or as a solvent. And again, this 6-member heterocyclic compound pyridine is the part of all alkaloidal compounds. Means for any alkaloidal compound, this heterocyclic compound is a must. Pyridine is a must. If there is no pyridine, no nitrogen containing heterocyclic 6-member ring is not there, it is no more alkaloid, and it will not be having hallucinating, or we can say antidepressant, analgesic, sedative effects. It is also used as a vitamin B complex. It is the part of lot of synthesis of vitamins. So pyridine is having lot of medicinal importance, lot of pharmacological importance, and lot of physiological importance. And pyridine, if we see the structure, it is like this. Here this is your pyridine, and numbering will start from here: 1, 2, 3, 4, 5, and 6. And then the other way of numbering in Greek, we have this type of system, means alpha, alpha, beta, beta, and gamma, gamma. So this is also one way of numbering the pyridine molecule. And pyridine is so important nowadays that without pyridine, lot of synthesis or lot of preparations for biologically active compound is not possible. So now number one, pyridine ring system, that is 6-member heterocyclic, is present in many natural products, means which are isolated from plant sources, maybe flower, maybe stem, maybe fruit, and can be in the form of alkaloid, in the form of nicotine, in the form of tobacco product. Any natural product is widely distributed. For example, in the form of vitamins, and nicotinic acid is one of the best vitamin. And also nicotinic acid is widely used if you have a rash or red eye. In that condition, the ophthalmologists, they recommend to take nicotinic acid is a vitamin just to clear the red thread, rash or red eye. It is very effective vitamin for your red eye to remove it. That is called nicotinic acid. The vitamin B6 Vitamin B6 is nothing but it is pyridoxine, is a derivative of 6-membered pyridine, aromatic compound. And also it is the most important part and nucleus of alkaloidal compounds like heroin, cocaine, and opium, cannabis, so many drugs which are alkaloidal in nature. There must be 6-member heterocyclic compound that is called pyridine. And that's why pyridine is very, very important. I told you already, it is the excellent and super organic solvent. And that's why in most of the industries where they are dealing with organic compounds, synthesis, isolation, preparation in pharmaceutical industry, drug industries, pesticide, insecticide industry, pyridine is a must. And nucleotides. Your nucleotides are genetic material. In DNA, RNA, in nucleic acid, also this type of pyridine nucleus 6-member heterocyclic compound is there. Number 2, how pyridine is isolated? It is isolated from coal tar, the oily liquid. So pyridine can be isolated from coal tar, and the light oil fraction in which it is present in good quantity and is treated with sulfuric acid. The acid layer containing pyridine and other impurities or bases. Again it is basified with sodium hydroxide, and that liquid is carefully fractionated, fractional, either fractional separation or fractional distillation, means with different fraction A, B, C, D. The pyridine is 100% purified. So pyridine, I have already told you that it has Greek terminology and also Arabic numbering 1, 2, 3, 4, 5, 6, and in Greek it is called alpha, beta, gamma. And these substituents, the preferred substituents are methylation, methyl group. It can be 2-methyl substituted or 4-methyl or 5-methyl substituted products with their different name, and also it is found in isomeric form. The second thing is that it is base because it will react with hydrochloric acid to form the salt, that is pyridine hydrochloride. So here I have given these structures. Once the numbering is from here 1, 2, 3, 4, 5. If the methyl group is attached to number 2 position, because in heterocyclic compounds we will start numbering from heteroatom. So the name of this is 2-picoline. And if it is at 2 and 4 position, then it is called 2,4, that is lutein. And once it is substituted at 2, 4 and 6 position, then it is called choline. So the mono, di and trimethylpyridine are commonly referred in terms of name are picolines, luteins and choline respectively. Number 4, the individual isomers are also known as, if carboxylic group is substituted here with picoline, it will be named as picolinic acid. And if without substituent of methyl, then it is called isonicotinic acid. Number 5, pyridine forms salt in presence of acid. This reaction clearly indicates that pyridine is a base. It can react with acid and it can form salt. So here I will stop, and still I will continue in my next lecture the chemical reactions. It will react also with sulfuric acid, some other acids. Also there will be oxidation of this pyridine. So all these reactions I will be discussing in next lecture, along with its physical property and also the structure determination, means orbital picture, and how the pi electrons in 6-member ring are delocalized. Once again, thank you very much for watching the lecture.